Hello, Yawning Angel back again with another AMOS video, and in this video we're going to continue our journey by looking at anaglyph 3D in AMOS. In this video I want to give you an update on the anaglyph 3D program that I'd started writing in my last AMOS video. There's a link up here if you've not already seen that. Yes, that program has evolved from its humble beginnings, and I want to share its progress with you now. Also, one of my long-term viewers has submitted some code which will help with the configuration of the colours for your red-blue lenses, and that is really cool. So we'll take a look at that as well. Thanks, Frank. So, you know how this works. Grab your 3D glasses and a cup of tea and let's dive on into the code. Right, here we are then. We're going to be recapping on the code, but before we do that, cup of tea time, this time using the RMC official Cave Dweller mug 2022. Seems like a lifetime ago. Oh, that's a good cup of tea. That's really good. Right, let's get on with it then. So the original program, if you've seen the previous video, you'll know, but for everyone else, I'm just going to quickly recap this. So I did a program around anaglyph 3D. So this is using the red-blue lenses so we can get a 3D effect. So the program effectively drew some black boxes, then it drew some red and blue boxes slightly overlain to give the stereo kind of 3D effect. Then I did some more squares and I did some more circles. So the reason I did the black squares was to give a sense of depth. When you put the old 3D lenses on, you got a sense that the 3D objects, the red-blue objects, were floating above the black objects in the background. And that worked really well. So then I did this kind of longer grid, and eventually I got this one simple circle, which I put under joystick control, and you could move around. And it gave a sense that it was almost floating above the background, which is actually pretty cool. And it was at that point I thought, could we do something more with this? And I have evolved this, and I'm going to take you through what it's evolved to and the journey that I went on to do that. So after doing that, I evolved the program a couple of times in order to create some sort of shooter. So we'd have our circles at the bottom of the screen shooting firing up the screen at some targets, and that's evolved into this program. So it goes through and it sets up the colors. There's still a lot of debug code in here, so excuse that. Now this bit here, what it's doing, it's drawn, you'll probably notice we've got two lines, two vertical lines, a red and a blue, and then we've got the circles, we've got the red and the blue circles as well. Now what it's done, it's created these, it's drawn these in the program, and it does a get bob command and turns these into bobs. Then it creates a grid on the screen, and what I've got is some targets. Now the little red and blue squares you see there, they're actually bobs that are created in the object editor. So these are just populated randomly on the screen, and I can take a joystick, and if I turn my sound up, we can blow them up like that, and we can move our circle around the screen. Now you'll notice that as we move it, we can see the background, so it's using a transparency on there, and we can just float around the screen shooting squares, and when they get shot they turn into circles and fly up the screen. And once we've cleared a level, they repopulate at random locations. The only problem is during the animation of the circles going up the screen, you can't control the joystick because that's just code within the program that's doing that animation. I'm not using AMOS or anything like that. Once again, this is just a bit of a proof of concept, but it kind of works. So yes, a little bit slow, but like I said, proof of concept, and it's a bit of fun, and it seems to work okay. But after doing this, I wanted to go and advance it a little bit further. And we'll look at that in a moment. But before we do that, I want to show you the lens calibration code that viewer Frank sent to me, which I think is pretty cool. So we'll do that next. Now, this part is pretty cool. So regular viewer to my channel, Frank, has sent me some code which will enable you to configure the blue and the red on the screen so it actually matches the blue and the red of your lenses. Now, in the programs I've done so far, I worked out what colour blue and what colour red I wanted. That is detailed in the previous video, so I won't go into that again now. So it was working okay for me, but obviously everyone's lenses are slightly different. So Frank has given this awesome code, which I've got in one of my demo programs. So I do want to quickly put a caveat on this and say I have not implemented this in the latest version of the program. I want to do a little bit of work with it in terms of that integration. So Frank, it is coming. I will use it. So I'm just going to show it for now. But in the latest version of the program, it isn't there. So this is another demo version of that program. So when I run it, the first thing we get is, well, look at that. It gives you the color blue on the screen. And like it says, while looking through the blue lens of your 3D glasses, use the O and P keys to adjust the color. Frank, I did change that little bit of code just in case you're wondering. So until it is nearly gone. So basically, when you're looking through the blue lens, you shouldn't see the blue. It should actually vanish. So if I go down, you can see the color changing, and at the bottom there, it's actually giving us the hexadecimal value, I believe, of what that blue is. So, you know, we can go through a range of blues, as it were, and get that to match the blue of your lens. When you're happy with the blue, so if we go to quite a bright version of that blue, if we hit spacebar, now it'll switch to the red, and you do exactly the same for the red. You look through your red lens until the red is nearly gone. So we can use O and P, and we can cycle back through to get quite a dark red, almost to black. And if we hold down P, we can then go up to the other end of the spectrum to get a very bright red. So, and as you can see, the code is showing there at the bottom. I think I've added that bit in, Frank. I might have just played around with that because I wanted to see what it was. I can't remember, so forgive me if I've messed up some of this code. But the concept of this is absolutely brilliant. And you're probably there going, well, Yawning Angel, why aren't you actually looking through your lenses? Because viewers of the previous video will know it's quite difficult to have them on for a long period of time while not looking at the screen and looking at a camera with a bright light shining in your face. It gets a bit headache inducing. Anyway, so if I do quite a dark red, and you know, we can hit space, then that actually will lock those colors in. It doesn't in this program. I've just put that piece of code on top of an existing program. It hasn't actually changed the colors in here yet, but it will do in a later incarnation of this program. But I think that is pretty cool. So thanks ever so much for submitting that, Frank. It's appreciated. Right, okay, so you probably noticed my 3D lenses are on because now I want to show you the latest incarnation of this program. Where are we now with it? So let's press F1. So the grid is defined there already. And I've got the vertical lines for the laser beam, the bullets as it were, and I've got the circle defined. The program is doing a get bob on those two. And when I press the space bar now, you're going to see the latest thing that I've added to this program just to make it a little bit more interesting. Oh yes, we've got a scrolling background. And I must admit, with the 3D lenses on, that does look pretty damn cool, because everything is hovering over that scrolling background. And I can move my circle around. You notice it's color 0 is transparent on here. We're using all sorts of things on here. So to do the screen scrolling, we're using screen offset. So there was a video on that. There'll be a link up above to that video. I've used get bob to do the circle and of course the laser beams. So let me turn my sound back up. And I've used the object editor to create these squares. These are actual bobs that are created. So it's pretty cool actually. So I can scroll, fly around, fly. Well, yeah, I think it's flying. And you'll probably notice there is no animation for the explosion now. I've taken that out, and there's a reason for that. But we can go around, we can shoot these. And that's it. It doesn't repopulate yet, but this is as far as I've got with this program now. And I'm actually quite pleased with how this has turned out. So what I think I'm going to do is just give you a quick overview of the code, what's doing what. Everything in this program we have covered in previous videos. So you can always go back and check out some of my previous AMOS tutorials and see, excuse me, how I've done some of this stuff. But this is actually quite a good effect. And with these lenses on, That is mad. That circle is actually hovering above that background, and it does look pretty neat. What I'm going to do quickly, let me just stop the program, I'll rerun it, and we'll put it full screen so people who maybe want to try with some 3D lenses can have a look and see what it looks like. So let's run that again. Here we go. So full screen for this one, but there it is. As you can see, circle just seems to hover above that scrolling background, and I can shoot these squares. The laser beam, I think, is kind of 3D. It does seem to be hovering over that background. If we do it from a further away distance from the target, yeah, I think that's kind of 3D. And we'll do this one. And that is it. Right, let's take a look at the code and see how I've done some of this. Right, here we are in the code then. So the first thing I'm doing is setting a default palette. This will change because I will use that lens calibration code to replace this in a future version of this program. But for now, I've just set, excuse me, I've just set the default palette here. This takes into account first color, well, color 0 is transparent, and then I've got my blues and my reds defined. Because I'm using dual play field here, I've had to define the color twice because I'm using 8 colors. So the first 8 is for one screen, the second 8 is for the next screen. We get a horrible color change if we don't define the actual colors. I've covered all this in previous videos, so that's why that's defined up there. I won't go into that again. Right, we open our first screen. Because we're using screen offset to do the scrolling, the first screen is 320 wide by 400 deep. We then go into a procedure called set background, which will unsurprisingly set the background. Yes, I've used a lot of procedures in this program, and as Dudley from Yesterdezine will tell you, I like an AMOS procedure. Right, so the set background procedure, all it's doing is setting our vertical lines and our horizontal lines. There's a gap of 20 pixels between each one to give us a grid effect. Right, back up to the top then. So after we've done the background, we do a screen copy. On screen 0, we copy the first 200 pixels to the second 200 pixels, which gives us that 400 pixel deep screen. We then open screen 1, which is 320 by 200, do all the usual stuff there. We do our dual play field command. We then go into a procedure called gen bobs, and this is for generating the relevant bobs for the screen. So let me quickly dive down to that. So here we are, gen bobs. So the first thing it does, it loads from our image bank, our ABK file, because we've got some bobs defined in there, and I'll show you those in a moment. Then what it does, it draws the 3D circles, and it calls a procedure called CCL, passes in the circle parameters and the color, and it does that twice and generates us our player circle. Then it does a get bob, so it captures that bob. Then it does our laser lines, so it draws them as well. So ink 4, ink 1, draws the 2 lines, then does a get bob, so it will treat that as a bob as well. So the circle is bob 1, then bob 2 is our laser beams, and then I've got a wait key in there, which I'll probably remove at some point. There is still some debug code in this program because I'm still evolving it, so some stuff will be removed. Don't forget, you'll be able to download the source code for this program as it stands at whatever state when this video is released. You'll be able to get that from my website, link in the description down below. And that's download for free, of course. Right, so when we come out of here, well, I'll tell you what I'm going to do. Let me go into the object editor and I'll show you those bobs. So this is it in the object editor. So because I've run this program, so it's already done the get bob. So bob 1, then this is from the get bob command, is our circle, as we saw in the code. Get bob 1 gets us our circle. Get bob 2 gets us our laser beams. Bob 3 is what I actually defined as a standalone bob. So this is our target. So that's nicely defined there. Actually, can I make that a bit bigger? There we go. So that's quite nicely defined. And then we've got our explosion bob. Now this doesn't actually appear in this program, but Bob 4 is our explosion circles. We can make use of them later on, but for now, this is not being used in this program. But there you go. There's our image bank. 3 and 4 are defined in there from the off, and the program creates Bob 1 and 2, does a get Bob and loads them in to the bank. Standard AMOS stuff with Bobs. It's all good. Okay, more tea needed. Second cup of this session, not necessarily of the day. Right, so after we've done our Bobs, the usual things, we make mask, we do double buffering, set auto back to 0, update off. We set some variables, we set some global variables, we set some more variables. I've got some arrays here, which I was using. I'm not too sure. These might come out before I upload this program, but we'll see what happens. Then got another procedure here called setup targets, and it takes in a value of TG. And I think up here, I set TG to 5. So we're just setting 5, I want 5 targets on the screen. So let's go down to targets, there we go, targets. So we just basically a for next loop over the TG value. We do a repeat until on these because basically while I'm generating these at a random X and Y position on the screen, I need them to sit within the grid in the background. I just thought it'd be a nice touch. So I'm doing a mod 20 check on those to make sure they are obviously divisible by 20 with no remainder. And they sit therefore within those grids because the grids are 20 pixels wide. Once I've done that, I then set the Bob. So it's Bob 3, which is our target Bob. And that on the screen is going to be +4 to whatever value Tn is. So the first time through will be 1 + 4, which will give us 5. So Bob 5 onwards will have our target Bobs in them. That's the way I've done it, and that works. Once again, covered all of this in previous videos on how to manage your Bobs. Right, so that is the targets procedure. Then after we've done targets, then we go into the main game loop. And here it's really straightforward. So we decrease the value that we're going to be scrolling the screen by. We're using our screen offset. Once again, covered all this before. Then we do a Bob clear command, so it clears all the Bobs from the screen. Then we go into a bullet update procedure. So this is if you have fired, you press fire on your joystick, and is there a bullet flying up the screen? So we need to go to bullet updates. Let me try and find it. There we go, bullet update. And basically it's saying if the bullet is active, set its Y coordinate so it scrolls up the screen. Make sure it's within the boundaries of the screen, so turn it off once it's left the screen effectively. That is Bob 2, which is the bullet. So this bullet update is just controlling the scrolling of that Bob up the screen and then removing it once it gets outside of the screen's boundaries. So that is bullet update. And after bullet update, yeah, so render the bullet if it's running. So if the bullet active flag is set, we then Bob 2, position it, LPX, LPY, or X and Y coordinates for that, and it is the second Bob. Bob 1 is our circle, which is controlled by the player using coordinates CX and CY. So as you move the joystick, CX and CY change. We have a hit detection procedure. Regular viewers to my channel and regular viewers of these AMOS videos will know that I love a hit detection procedure. And if I can find it, let's go hit detection. So if Bob 2, which is the laser beam, if that's hit a Bob from 5, and I've set it to 20 for now because eventually we're going to have more targets on the screen. Basically turn off the laser beams, set bullet active to false, handle the explosion. Now at the moment there is no explosion as such, but we turn off the Bob that was hit. So we do this here, so we loop through 5 to 20, those could be our targets. Once again, 20 is a bit optimistic here, so it's only 5 targets on the screen. But anyway, if we've got a collision on that Bob, we turn it off, we increment a hit counter, job done. Quite simple, really. That's our hit detection. And back up here, so we do our hit detect. If the total of targets have been hit, reset and repopulate. At the moment, nothing is happening, but what we would do is once we've cleared all the targets, we can either move to another level within the game or repopulate with more targets. I've still yet to do that. Then we issue a bob draw command, do a screen swap because we are doing a dual play field. All this was explained in a previous video. Wait VBL command. And after that, we're just doing checking our joystick. Have we moved right? We're using increment. If we move right, if we move left, we're using decrement. If we go up, we decrease our Y value, and if we go down, we increment our Y value. Yes, I'm using inc and dec on this because I've learnt my lesson. If you press the fire button, set the bullet active flag to true, and then to get our bullets moving, we go into a procedure called FR. And if I can find FR, here we are, FR. Procedure to handle what happens when fire is pressed. Play the sound, shoot, set the bullet active to true. I think I've already done that. Might need to remove that line of code. We get the starting position of the laser beam, so it appears at the center of the circle bob. So we know where our circle is on the screen, and we take those coordinates and we do a +10 to the X value. So that puts it in the middle of the circle, and then we do a -12 on the Y, which puts it at the top of the circle. So it looks like the laser is coming from the middle top of the circle, which I think is quite cool. And that, ladies and gentlemen, is pretty much it. That's all the program is doing, and I'm quite pleased with that code. And I think it works a treat. So there you go. Go and download it. But wait, before you go and download it, I need to ask, do you think this program is worth pursuing? Should I add more features into this? Should I turn this into a bit of a game? Should we have more targets appear after you've cleared a level, so we move through the levels? Maybe a bit of 3D eye candy on the screen. Now we know how the anaglyph 3D works. Is it worth putting some static score tables on the screen that appear to float over the background, make it look a little bit more interesting? Tell me. Do you think Yawning Angel, you've proved a point here, move on, do something more interesting because we don't want to know anything more about 3D in AMOS Pro? Or, yeah, this might be worth doing something interesting with. Let me know your thoughts in the comments down below. That would be great. Thank you. And that is it for another video. Thank you ever so much for watching. Please, please, please let me know your thoughts on this program and where I should take it next in the comments down below. Don't forget, the source code for this program is available to download for free from my website, and there'll be a link down here for that. If you enjoyed this video, be sure to give it a thumbs up, and if you want to see more of these AMOS videos, I've done quite a few now, be sure to subscribe to my channel. If you want to support what I do, you can do so on Ko-fi. My Ko-fi address is up here. Thanks once again to everyone who has supported me there. I really, really appreciate it. Thanks once again for watching, and until next time, whatever you do, look after yourselves and keep it retro.